Most of this stuff we do is going to be solving for a side length. So again, like your check is going to have to be, for this specific test, is first, is it a right triangle, which it's not, so you don't use the basic sine and cosine and tangent ratios. Then you would have to move into look at what's given to you to pick either law sines or cosines. Obviously, we're going to be doing law sines because I haven't done the other one yet. But you would see that you've got, this would be the two angles are given to you, and one side, which would be what I had listed up. You got two angles and a side length. To find something that's missing in the triangle, you're going to have to do law sines. Okay? All right, so what I'm trying to find is a side length, meaning I would hope that I have the angle that's directly opposite that side length, which I do. It's a good thing. Okay? So I would start this off by doing one ratio. I tend to, like when I'm doing this, the things that are missing, like whatever I'm trying to solve for, I keep in the numerators. So if I was doing like an angle, I would have the sines all on top. But since I'm finding a side length, I'm going to have the side lengths all on top. So sine of 48. So these two, again, those two are just opposite each other. You can call them A, B, C, it doesn't matter. As long as the side length and the angle are opposite, you can put them in a ratio. All right. The other thing would be, I need another side length. There's only one given to me, so that's the only number I can use. So that's 56.9. So then again, what I'm going to put below it is going to be the sine of an angle. All right, and it has to be the angle that is directly opposite that side length, which there's nothing there, but you should be able to figure out what it is. 76? Is everyone okay how the 76 came about there? What? For the sake of trying to keep it a little bit simpler, before you do the cross multiplying, I would say make the sines of each angle into decimals. Like sine of 48 is, I don't know, I don't have these written down. What is sine of 48? Somebody open it. Wait, what? And then what's sine of 76?
0.9702.
Okay, so like the whole point of doing that was so that now if you see this, you can see that this is a number, not like a word with something else there. A lot of times when people leave it this way, when they start doing like cross multiplying, they'll do 48 times that, which is wrong. Okay, you want to do the sine of it first, then do the cross multiplying. Okay, so if I do like a full cross multiply, this would be like 0.97 times x equals 56.9 times that, which I don't know, what was that?
42.276.
No, I'm not there. You're right. Yeah. So when you do that full, then when you divide that back out, you should get like 43.6 or something like that. It's not a right triangle, so I couldn't use the basic ratios, right? The right triangle one. So it means you'd be either doing sine or cosine, like the law sines or law cosines. Again, it's obvious we have to do the one because I haven't talked about law cosines yet. But if this was a test, you would look and see I've got two angles given to me and one side length. That fits for law sines. Remember, if it says solve, just remember that means find everything. So like find that angle, find that side, find that side. Okay? Probably if I give you a solve one, it's going to be one that's more straightforward like this, where the angle is quicker to find. So you're not stuck doing like too many of the inverse trig ratios to get it. Okay, so first thing I would do is write out the work for that. But again, I would hope everyone should be able to find that angle, yes? Okay, it's how much? 114. 114. So that was just the 180 minus. Okay. And then once you have this, now I can find both. I could set both the ratios up at the same time because I've got the angles that are opposite each side. So I know if I was finding, let's say, x first, that's the angle opposite it. So I would know I would have one ratio going like that. The other side of that to create the proportion would have to be the one that has both numbers in it, meaning I would have to use 65 and sine of 114, because that would give me actual numbers there. If I threw y in there, that wouldn't do me any good. All right, but since I know this side has numbers, I can go ahead and set the other one up at the same time. Okay, just because, for both of them anyway, you would want the one side to be the same, because you want to keep probably the numbers that are given to you consistent. Like I wouldn't want to find x and then use it to find the other one. So again, I would do this kind of the same way, like I would find decimals, like what's sine of 20? Somebody do that for me?
0.34.
3-4?
2.
Yeah, sure. And what's sine of 114? Point what?
9.4.
And what about 46? Sine of 46?
0.72.
Okay. And then like I said before, look, the whole point of making them decimals is so that when you cross multiply again, you can actually see that this is a number, that's a number, as opposed to a word with something by it. Just so you don't make the mistake of going like 20 times 65, you do 0.342 times 65. All right. You should get, which one's that? X I put as AC. You should get 24.3 here. Or I don't know, close to it. And this one was 51.2. Or somewhere around there. I don't think I rounded when I did it. These might have been rounded, so it might be a little different. The situation where now I've got two sides and a non-included angle. Okay? So when you're setting this up, I would still, like in my head, if this was a test, I would say this is what's given to me. Because this angle's not, this would be the included one, this is not included. So this would lead me to go, oh, I need to do lost sines. I'm trying to find an angle, so like I said, you don't have to do this, but in general, whatever I'm trying to find, I keep in the numerators, just because if you do cross multiplying, all that stuff, if you leave this on top, you just have to really multiply that over to get close to your solution. This angle here is opposite that side. So again, I need like whatever angle I'm working with and the side that's opposite need to be on the same ratio. This is the other angle given to me. And I'm allowed to do this problem because they do give me the side that's opposite it. So I know the 120 and 45 are opposite and the theta and the 36 are. Okay. All right, so what you're going to have to do here, probably to make it easiest, is to go ahead and make this like whole thing a decimal. Like do sine of 120, then take that number and divide it by 45. Like so do this separately. Like do sine of 120 divided by 45 and make that one thing a decimal. All right? Can someone do it for me? Like 0.0 what? 19. Okay. And again, the whole reason I put this in the bottom, like whatever I'm trying to find on top, is so that for me to isolate this, you just have to take that number and multiply it over. So like 36 times 0.019 is going to tell me what sine of theta equals. What's 36 times that? 2? Yes. And then remember, guys, to get the theta now, this is where you do the arc sine, which is the sine -1 thing. So everyone's calculator should have that function on it. It's usually second sine, if you forgot where it's at.
Can you just divide it by sine?
No, there's nothing to divide. Would you say 43 point what?
0.9.
Okay. When this comes time for like your test, your whole thought process would have to be, here's the triangle, I got to find the side length. It's not a right triangle, so I can't do the basic stuff. Nothing fits the law of sines because this would be your two sides, and this is the angle that's between the two sides, so it's the included one. So it's a matter of you kind of have to have your situations memorized as to when to apply each rule. So again, this will be a situation where you're doing law of cosines, so you've got two sides, included angle. The side you're trying to find, again, is generally opposite that angle that they give you, unless they give you enough angles to find it. But these would be, this is the angle that you're going to be taking the cosine of because that's opposite the side you're trying to find. Okay? So that means that this side I'm trying to find is going to be the one that sits completely by itself. That's going to be the x squared equals. And again, like I said, it kind of starts out the same way as Pythagorean theorem starts out. All right? Where it's like a squared equals b squared plus c squared, or however you want to say it. Okay? And then after that's where it goes usually haywire for people. They freak out because it's got a subtracting and there's twos and cosines and all that stuff. Gosh. All right. Whatever numbers you use here, or if you have variables here, whatever, are going to be the same numbers you copy here. So if you have a variable in this part, which wouldn't make sense, you would also put it there. And then at the end, it's cosine of whatever's there. All right, so here's where mistakes get made. What I would suggest you do. What I would suggest you do is you square the numbers that need to be squared. Like separate each thing. There's 3 numbers up there. Okay? Like this right here would become a number. Like what's 15 squared?
245.
And what's 18 squared? Okay? There's 2 numbers. This whole chunk right there, guys, needs to be multiplied together. There's nothing added or subtracted there. It's 2 times 15 times 18 times the cosine of 108. Okay? So in your calculator, you literally have to multiply all those 4 numbers together to get what you're subtracting. All right? I would assume this is negative because cosine 108 is negative. So what is 2 times 15 times 18 times cosine 108?
Negative 166.9.
0.9. Okay? Where people mess up is they'll try and like add this chunk together and then do cosine at the end. That's incorrect. All right? This is one number. This is a chunk that you need to multiply. Okay? So if you combine all that together, what's that? 715? Wait, what is that? 0.9. And then square root of that would be your answer. What is it? 20 what? Guys, the last bit is area of a triangle stuff. So here's the thing. Usually, gosh. Alright, so here's the thing. Usually that's going to be the only formula people remember with this. Okay, like, because that's what's given to you from day one with, here's the triangle, find the area. But for this formula to be utilized, really you either have to guys, please be quiet. For this formula to be utilized, you either have to know the height or it's a right triangle. Okay, so if they don't flat out tell you what the height is, there's no point in wasting time finding it because we got other formulas to work around it. If you have a right triangle, the legs are your base and height. So if you had a triangle like this, that was 10, and that was 8. Of course, it'd be 1/2. 10 times 8. So that would be 40, whatever the units are. Okay? So if it's not a right triangle, if it's not a height given to you, most of the time it's not efficient to find the height and then plug it in. Like you get the correct answer. It's just going to be, you're going to do so much work that it's not generally going to give you enough time to complete anything else on a test. All right? There are 2 other formulas. Sometimes they get brought up in geometry, sometimes not. It really depends on time. So for a triangle, if you know 2 sides and included angle. Okay. So here's the thing, and the other ones are for triangles that are not right triangles. Because again, if it's a right triangle, the 2 legs would be your base and height. There would be no need to do the other formulas. All right, this is saying that I know something like 2 sides. Let's say, give me a number.
74.
Oh my God, 84 and what? 19. We'll make this 30. Okay. All right, so that would be a situation where there's 2 sides, an included angle. The height's not there. It's not a right triangle, so I'm not doing anything with 1/2 base times height. Okay. The way this formula works is if I drew up like my, all right, if I drew up like the generic triangle that has been up there, okay, for law sines and cosines, I can write a formula for the area of this non-right triangle. The way it goes is 1/2 AB. These would be the 2 sides you know. So like in this case, if I wanted it, I can just do 1/2 84 times 19. Okay? And I'm not done because that would be kind of like this formula. That's not the same. Then you want to do that multiplied by the sine of the angle that's between them. So like in this case, I've got the 2 sides. This is the angle that's between them. So I'm going to do that. So you multiply all those together. Like find sine of 30, multiply it by 84, multiply by 19, divide all that stuff by 2. Someone do that for me? What's all that multiplied together? Huh? 330? It might be.
Choosing random numbers that makes no sense. So.
I don't know. Multiply there.
Yeah, 300.
It's 42, then 20, 21 times 19.
Oh, it's 99. You're right, Ashton.
99?
Yeah.
It's not drawing a scale.
This would be a situation where I don't have any angle measures, like I don't have the 2 sides and the angle between them. It's not a right triangle, so I don't have base and height. For this one to work, this would be you have to know all 3 sides. So again, these things kind of save you time as opposed, like if you had all 3 sides, if you wanted to do it with 1/2 base times height, you would have to take the time to find an angle, okay, correctly. Then you would have to take time to now draw on the height, then use other trick stuff to find the height, which is a viable option. Just way too much work. Okay, for this one, the first thing you have to do though is find the thing called a semi-perimeter, which is just the perimeter divided by 2. Okay, everyone should be able to find a perimeter. You add up all 3 sides. So again, I'm doing this with a generic triangle as A, B, and C. So S, if you look up this formula ever, they'll have S as the semi-perimeter. So it's just 1/2 of everything added up. Okay? Then the way the formula actually works for area is it's a big square root. All right? The square root part will be the last thing you do. underneath the radical here is there's 4 numbers you multiply together. You multiply whatever the value of S is, okay? And then the other 3 is just the difference between the S in each side. So like S minus A, E, S minus C. So you take the semi-perimeter and you subtract each side separately. Those are the 3 numbers. You multiply all these 4 together. So these are the 3 subtracted times the semi-perimeter. So we'll do that one, all right? This will be the last example. So again, like if you were doing this problem and I said find the area, like your checks would have to be there's no angles, so I can't use the one that was just up there with the 1/2 AB sine C. It's not a right triangle. I don't have the height, so I can't do regular 1/2 base times height. So that means for me to find the area, I have to do this Heron's formula. Okay, so first thing I would do is do the semi-perimeter, which means add up all the sides and divide it by 2. Which says 48? Okay. All right, and then for your area, guys, so the big square root is going to be 48. That would be the S. Then again, separately, you go around the sides and you subtract each number from it. So like 48 minus 12. 48 minus 44 minus 40. So this is like 48 times 36 times 4 times 8. Okay? Like when you get used to this one's actually a quick formula because you don't necessarily have to write the subtractions. You could probably skip right down to this part. And if you do this correctly, like if you multiply everything and square root and stuff, you'll get, there you go.